Okay. All righty. So thank you all so much for inviting us for today. I'm Liz Kiernan. I am currently a member of the Broad's pipeline development team, and today I'm joined by Kaylee Mathews, who will introduce herself in a moment. But we are excited to tell you a little bit about WARP today. That's the Whittle Analysis Research Pipelines Repository. It's a collection of cloud optimized workflows for biological data processing and reproducible analysis. So before I dive too much in, I wanted to kind of answer the question, why cloud pipelines? As many of you know, large consortium and organizations are generating more and more data every day. A couple of years ago, the Broad genomics platform alone was producing over 45 terabytes per day with all the sequencing of the whole genomes and exomes that they were doing. And traditionally, our team has worked with different organizations to create analysis pipelines that can handle these different kinds of biological data. So whole genome data, exome data, and single cell sequencing data as well. But we a couple of years ago, as I mentioned, we kind of hit that breaking point too, where we needed our analyses to scale with this growing data. And the cloud is a great way to scale analyses because the cloud can expand to meet your needs. But more than generating scalable analyses, the cloud allows us to be fair, basically, to allow data and analyses to be fair. And if you're not familiar with that acronym, it's findable, accessible, interoperable, and reusable. And that's kind of the goals of a lot of these larger consortium, including the AnVIL, to really help share data and analyses so that we can accelerate science. And pipeline reuse and reproducibility is a part of this process. So that was another huge motive to move to the cloud. And it was the starting point for why we developed a specific GitHub repository for cloud-based pipelines. So today I'm going to introduce you to that repository and the key features of it that help us make our pipelines fair, essentially. And a couple of things I want to note about the pipelines in the repository. As I mentioned, our pipelines are used to analyze all different kinds of biological data types, from whole genome sequencing to RNA sequencing, ATAC, methylome, et cetera. These pipelines are open source. They are GA4GH compliant, and they're written in the workflow description language, or WDL, which is a portable workflow language that we use in the AnVIL. And it allows you to run things on-prem, but in the cloud as well. All right, so there are a couple of key features about this GitHub repository that I wanted to call out for you today, starting with the fact that it's public and open source. I'm going to talk to you a little bit about how we support provenance and scientific reproducibility, how we try to provide transparency and make the pipelines easy to use, and how we get engagement from the scientific community, the larger scientific community. So we'll start with this public and open source first. So just to let everyone know, the pipelines and the whole repository are under a BSD3 open source license. So this includes the actual WDL scripts, the repository, all the tools that we build in there, the Docker containers that we build that host our tools, and build scripts as well. So anything that we're using to build Dockers and build tools. And it also includes the inputs that we use to test these pipelines. So that's going to be test data, reference files, interval files, the things that you need to actually run the pipeline. We document the pipelines. We have overviews for most pipelines in the repository, and we have contribution guidelines, which are always in progress. We do encourage people, if you're interested in contributing, we have guidelines for both our documentation as well as the repository itself. We do develop pipelines for larger consortium. So when it comes to bigger changes to the pipeline, we ask people to file issues in the repository, but we do need to be mindful about how we're changing pipelines, because we have to ensure that they do work for the needs of the different consortium that we build for. But we are open source, so please come in and check it out and file an issue if you see something you want changed. Next, I'm going to talk a little bit about how we support provenance and scientific reproducibility. So we have several key features in place to provide researchers information about how the pipelines are changing and to ensure scientific reproducibility. And these features are testing, which we're going to dive more into. So we have continuous integration testing on each pipeline. We have a rigorous review process in place where we do require pull requests and reviews on all pull requests to the repository. So if you're not familiar with GitHub, basically, if people want to come in and make changes, every change made to the pipelines has to undergo a review process. And we have branch protections in place to ensure that we're not just randomly pushing up any changes to the pipelines. We use versioning, we use semantic versioning, and I'll go more into the purpose of that and how we use it. And then we do have packaged pipeline releases. So we'll talk about how you can access these pipelines, including in the AnVIL later. All of these features are in place for two reasons. One, to allow researchers to understand how, again, changes to pipelines impact their analysis, and also to help us avoid unnecessary overhead as we're doing pipeline development. So let's talk a little bit more about the testing side of things and the review process. So each pipeline has scientific owners who choose test data, review our pull requests, and investigate any test failures. So we have automated tests that check for any changes to scientific outputs. We have two main tests in the repository. One side of things is plumbing tests. These run on every single pull request that people push up to what we call our develop branch. So we have 3 branches in place, a develop, a staging, and a master. And so any changes that are made to a pipeline initially go to our development branch in GitHub. And so every time someone tries to make a change, push up a change to this branch, we run quick plumbing tests that use small data. And this is going to test all the tasks in a pipeline to make sure that everything is still working the way we expect. Before we push up to master and release a pipeline, we run scientific tests. So these are going to be tests that run on full-size scientific data, and they're designed, the data sets that we choose are designed to capture different edge cases that a pipeline might use. And so one example of an edge case, we have single-cell RNA sequencing pipelines that can run on both single-cell mode or single nucleus mode. So when we run scientific tests, we use data sets that can capture the nuances of both those data types for running. Okay, I'll just pause there and see if anyone has a question. I hope I'm not moving too fast. So, okay. All right. So we also have in place smart tests and linters that can check again on every pull request that the pipelines are looking well. So for the smart tests, these are tests that are going to catch only changes that impact the pipeline. In other words, we're only going to run our plumbing tests on pipelines that are impacted by a change. So these are automated tests that we have in place that can go in and check what WDL tasks we're changing. So if you're not familiar with WDL, essentially workflows are made up of different tasks, and we modularize our pipeline. So we reuse tasks in different workflows. And so if we make a change to one of those tasks, these smart tests can identify which workflows also pull in that task and make sure that all pipelines that use that task are not impacted by a change that we make. We also run a linter in the background that's a syntax checker for our WDL workflows. So on every pull request, we also run WOM tool, and that'll check and make sure that any changes that we've made to our workflows still are within the WDL syntax. After we've run these tests, the review process still requires review from 2 engineers, software engineers. And again, if we've changed anything about the scientific outputs of a pipeline, we will also require review from a scientific owner on the pipeline. And we have special branch protections in place, again, just to reiterate that, so that no one can merge directly to develop staging or master. Everything has to go through this rigorous review process. We use semantic versioning. So if those who aren't familiar, that's going to be a major number, a minor number, and a patch number. And this provides researchers immediate visibility into how different versions of the pipeline are going to impact their analysis. So if there's a major change, major version change in the pipeline, that means that a researcher is going to want to reanalyze any data that was run with a previous version of the pipeline. If it's a minor change in the version, it means the scientific outputs might differ slightly, but are still within a reasonable noise. And then any patch changes, it's not going to change the actual scientific results. So for example, if you're producing a matrix with counts, it's not going to change those raw numbers in it. So that, again, gives kind of immediate access to how things are happening as we're changing pipelines. And the way we use this semantic versioning in the repository is to run, yet again, another automated test to make sure that any pipeline, that every time a change is made to a pipeline, that we are incrementing the pipeline version. So the pipelines are all versioned, and this is just an example of one within a workflow here. And when we increment, we also have to make a change log entry that goes with that incrementing. And so we have a test in place that ensures that if a pipeline is incremented, there has to be an increment and change log as well, and the numbers have to match. So this ensures that all the changes that we make to these pipelines do have documentation that go along with them. And as I mentioned earlier, we also have packaged releases of these pipelines. So if you're interested in running them, we're going to talk about a couple access ways, but from our GitHub repository, you can go on and find a version. You can search for version numbers. We tag all of the releases with the version number, and you can search those in GitHub. And then you can download all the assets with the pipeline in order to run it. We also pull in the latest changelog entry as an automatic release note here. Okay, transparency and ease of use. So as I mentioned earlier, we do have documentation for most of our pipelines. I'm showing one example of this overview here. We have a dedicated documentation site. We're very fortunate to be a team of software engineers, computational biologists, and scientific writers. So Kaylee works on the writing side of this, and we're very grateful to have her skills to help us keep the documentation updated. In addition to these overviews, we try to provide pre-written methods sections for the different pipelines. So if you're someone who's interested or has been using our pipelines, we give essentially a template that people can pull into a publication maybe that researchers are trying to get out to make it easier to write up about the pipelines. And in terms of ease of use, we have 3 ways of accessing the pipeline. So I already mentioned that you can download releases from GitHub, but a more popular and perhaps easier way to use the pipelines is through DocStore and running an AnVIL. So all of these pipelines are automatically pushed to DocStore, and from DocStore, you can run them, download them, or you can export them to AnVIL powered by Terra and run them there. And if you are interested in exporting to Terra, I'm just showing an example from the DocStore page here. You'll notice a launch with icon anytime you come to a version of a workflow in DocStore. And so here you can see you have the option to export the pipelines to AnVIL. And in a moment, I'm going to turn this over to Kaylee, who's going to show you how you can find these pipelines on AnVIL. We do already have example workspaces preloaded with these, so she'll show you that in just a moment. Let's see, I see a few things coming in the chat, so I just wanted to answer questions here. Can we tell the major minor patch update based on the version number? Yes, so the version number, the V like 2.3.4, that is so the 2 is the major number, the 3 is the minor, and the patch is the 4. And so if you see a pipeline go from, say, version 2.3.4 to version 3.0.0, you know that a major change has happened because we've changed that major number there. And so that tells you right away that you're going to need to reanalyze data if you've previously analyzed with an earlier version of the pipeline. Thanks for the question. Okay. All right. The last thing I just wanted to cover briefly is the community aspect of this. So in making these pipelines, we do make our own tools to meet different needs, but we also work very closely with the greater scientific community to help whittleize their existing pipelines and bring them to the cloud. So we collaborate very closely with scientific experts on these pipelines. We also collaborate with tool developers. And another important aspect of our development process is making sure that the outputs of these pipelines can be pulled into other downstream community tools. So it's important that if people are, again, going back to the RNA sequencing example, using Seurat downstream, using ScanPy downstream, using CellBender downstream, that we make our outputs compatible with those downstream tools. So we do actually work with some of the people who make the downstream tools as well to make sure that that can happen more seamlessly. And on a whole, we do have engagement from the global scientific community. Even if you look at our documentation site alone, we've had over 1,080 visitors from around the world in the last 6 months. So people from all over the world can come and use these pipelines, hopefully, and we get contributions to the repo over time from these folks. So we're very grateful for that. All right. So I am going to hand this over to Kaylee, but I want to show the acknowledgement slides for our team. Like I said, we are a dedicated team of software engineers and comp bios and science writers. But also a huge thanks to all the many people who have supported the pipelines over the years, and especially our team alumni. And I wanted to call out Kylie De Gaetano, who previously helped push forward the Warp repository, the creation of it, and also developed the basis of these slides, and Rex Wang, who was the initial person to help make our documentation site as well. And I can share a PDF copy of these slides in the chat if anybody wants it for the links inside here. So I'm going to hand this over to Kaylee now, who's going to show you a live demo of the pipelines in AnVIL. I'll stop sharing.
Great. Thank you, Liz. As Liz said, my name is Kaylee Mathews. I use she, her pronouns. I am a senior science writer at the Broad on the user ed team, but I also work closely with the pipelines development team, as Liz mentioned. So I'm just going to go ahead and share my slide, or my screen, excuse me. So what I want to show you guys today is basically how you can find Warp workspaces on AnVIL powered by Terra, and kind of what is in those workspaces, what you can do with them, etc. So here I am here on the AnVIL powered by Terra homepage, and I want to find a workspace. So I'm going to click on this menu icon and click on workspaces. And now the Warp workspaces are public workspaces. So I'm going to click on this public tab here. And now we have a really convenient way for you to find all of our Warp workspaces, and you can find them by clicking on this tags dropdown and then clicking Warp pipelines. And so now in this public tab with the Warp pipelines tag on, I'm going to be able to see all of our public Warp workspaces in this list here. So that's how you can find them easily. Now, I want to show you what we have in some of these workspaces, what you can do in them. So I'm going to open one up here. I'm going to open up this HCA Optimus pipeline workspace. This is our dashboard. And so the dashboard of a workspace is going to tell you a lot of really useful information, especially for these workspaces. So basically at the top here, you're just going to have some information about the workspace and the pipeline. You can see who we developed the pipeline in collaboration with, the version of the pipeline that's currently in the workspace. You're going to see a description of what the pipeline actually does here. So we're telling you what the Optimus workflow does. Importantly, on all of these dashboards, we have a link to the documentation site that Liz showed. So if I click on this for more details about the pipeline, see the Optimus overview in the Warp documentation. So if I click on this Optimus overview here, that's going to take me right to this documentation site, to this overview document for this pipeline, where you can see even more information than what will be on the workspace dashboard, right? So we have the diagram of what's actually happening in the workflow, descriptions, input descriptions. We have descriptions of the tasks that are being called. We have descriptions of the outputs down here somewhere, of the outputs here. So there's a lot of information in these documents for you as well. And you can see that some of these pipelines have additional documentation as well that might be useful to you. I'm just going to go back to the workspace now and continue showing you what's in the workspace. So in addition to descriptions about the workflow or the pipeline, you're also going to see instructions for how to actually test out the workflow in this workspace. So you can see we have downsampled example data sets and workflow configurations already set up for you in this workspace, along with all of these instructions so that you can test this workspace on this downsampled data at low cost and relatively quickly as well. There's some more information about inputs here, some optional inputs, the outputs of the workspace. You can see estimates for the time and the cost to run on the different sample sets that we have in this workspace. And then you can see basically a change log for the workspace and then some contact information. Okay, so that's the dashboard. I just also want to show you quickly, if we click on the data tab, you can see we have data tables already loaded into these workspaces. So you can see we have some sets here. We have our sample data here, links to the file. So these are going to be that downsample data that you can use to test the workflow. And then we also have workflows already configured in these workspaces for you. So if I click on one of these workflow cards, you'll see that we have inputs already configured. We have outputs already configured to write back to the data table to make it easy for you to, again, come in and test these workflows cheaply and quickly. Now, the last thing that I want to point out in these workspaces is that you can actually see that we're pulling this directly from GitHub. So if I click on this link here to this source link for this workflow, that's actually going to take me to DocStore. That's where Terra is pulling the workflow in from. On DocStore, you can see this launch with AnVIL button that Liz was talking about. You can also see the source code for the workflow. And so if I click on that, you'll see that this takes me right back to the Warp repo. So it's all connected here. So you can get to the Warp repo from the workspaces. You can get to the documentation from the workspaces. So these are a really great resource for you for, again, information on these workflows, but also to be able to test workflows as well. So I'm going to stop sharing my screen. I believe that wraps up everything that I wanted to show you for Warp workspaces in AnVIL powered by Terra. So thank you again for having us here today. If you have any questions, you need to reach out to us. You can use that email that Liz had in the last slide of the presentation, that Warp Help email. And I think now we can take questions.
Wonderful. Thank you so much, Kaylee and Liz.